Today's lesson is on the domain and range of a function. At the end of this lesson, you should be able to find the domain or range of a function using equations, tables, and graphs. You should be able to write the domain or range using set builder and interval notation, and you should be able to create a domain to represent different situations. The set of inputs that result in an output is called the domain of the function. The set of outputs is called the range. Exercise 1. State the range of the function f of n equals 2n plus 1 if its domain is the set 1, 3, and 5. Show the domain and range in the mapping diagram below. So if we have the function f of n equals 2n plus 1, and our domain is 1, 3, and 5. So 1, 3, and 5. So if I plug 1 in for n, because that's where my domain is going to go, 2 times 1 plus 1 is 3. So 1 maps to 3. If I put 3 in, 2 times 3 plus 1 is 7. So 3 maps to 7. And if I put 5 in, 2 times 5 plus 1 is 11. So 5 maps to 11. So my domain is 1, 3, and 5. My range is 3, 7, and 11. Exercise 2. The function y equals g of x is completely defined by the graph shown below. Answer the questions based on this graph. Determine the minimum and maximum x values represented in the graph. So x is horizontal, so my minimum x value is right here. My maximum x value is right here. So -3 and +6. Now determine the minimum and maximum y values represented by this graph. So y is vertical, so the top of this graph hits here, and the bottom hits here. So my lowest y value is -5, and my highest y value is +4. So now it says to state the domain and range of this function using set builder notation. And it's very, very important you know the difference between your notations. So we'll notice in the box, set builder notation is the second one. It has the x such that and then the inequality. So it asks us to find the domain and the range. So the domain is x such that, and domain is your x values. So our x values, our lowest was -3 and our biggest was 6. So -3 less than or equal to, because there's a closed circle, which means it's included, x less than or equal to 6. And then our range is an x such that, it's y such that, and our lowest value is -5 less than or equal to y less than or equal to 4. And again, the bottom and the top, they're all closed circles, so they're all included. It's very important that you know the difference between interval notation and set builder notation. Example 4, or exercise 4. Multiple choice. The function f of x equals x squared minus 2x minus 1 is graphed on the grid below. Which of the following represent its domain and range written in interval notation? And I'll tell you, I like interval notation better because I find it a lot easier to write. So, domain, remember, is your x values. Well, notice your x values, there's an arrow. So what that means, it keeps going, and it keeps going. So that means our domain is either all real numbers with a capital R, or it goes from negative infinity to positive infinity. Another reason I like interval notation is you could write this in either order. So you could write infinity comma negative infinity, and that would be okay. That doesn't work so much with set builder notation. And our range, bottom, well, the bottom of our graph is here. The top, there's arrows. So our bottom is at -4, and it's greater than -4. There's a enclosed circle, so it includes -4, and it goes forever up, so that's infinity. So my answer is choice 3. So when there's arrows on the end, make sure that you take that into account, unlike exercise 2 that stopped without arrows. Our last exercise. For most functions defined by an algebraic formula, the domain consists of the set of all real numbers. Given the concise symbol R. Sometimes, though, there are restrictions placed on the domain of the function by the structure of its formula, and that is huge. 2 basic restrictions will be illustrated in the next few exercises. So the first one, it's a fraction, and that is huge because we already know fractions have restrictions, okay? So it says evaluate f of 1. So that means I put 1 in for the x value. See how it says f of x and then it says f of 1? So this means x equals 1. So if I put 1 in for x, I have 2 times 1 plus 1 over 1 minus 4. I'm going to put that into my calculator and I get -1. Oh, I don't even have to do that because it says from the table. So f of 1 is -1. Then f of 6, and it says x equals 6, is 6.5. You could just plug them in, but you don't have to. So now it says, why does the calculator give an error at x equals 4? And you'll notice if you plug it in the equation, 2 times 4 plus 1 over 4 minus 4. We have 9 over 0. Well, if we have a 0 in the denominator, that is called undefined. And that is an error on the calculator. In the TI Inspires, it will say undefined. Are there any values except 4 that are not in the domain of f? Explain. So look at this fraction, 2x plus 1 over x minus 4. The only value that makes x minus 4 equal 0 is 4. So 4 is the only value that cannot be in the domain. So your domain is all real values except for 4. That's hard, okay? So make sure you practice these exceptions because these are the hard ones. Exercise 6. Which of the following values of x could not be in the domain of the function y equals square root of x plus 4? Explain your answer. Well, I love the tables, so take out your calculator. Make sure you get a graph. So we're going to do the square root, so control x squared, x plus 4. Hit enter. Notice the graph. It starts at -4 and it keeps going positive. So the domain is from -4 to infinity. But how do I know if -4 is included or not? So hit control and then the T to get the table. And we're going to look at the value -4. Notice it has a value, 0. 0 is a value. So 0 is included. So our domain is from -4 to infinity. So they want to know would not be in the domain. So 0 is from -4 to infinity, 5 is from -4 to infinity, -3 is from -4 to infinity, but 4 is not. And how do we know that? Well, a radical, what's under the radical, has to be positive. Sorry, I'm off the screen. So x plus 4 has to be greater than or equal to 0. So if we solve this, x is greater than or equal to -4, which is the same as our domain of -4 with a bracket, which means included, to infinity. If you have any questions, make sure you ask. Good luck!